Hello everyone, welcome to the GeoEcolologist. I am Dr. Krishnanand and you have been watching my videos on oceanography. So in this session on oceanography, we are going to learn about the salinity distribution, the factors controlling salinity distribution and other related concepts. But before we go ahead, don't forget to subscribe to our channel and do share the videos with others as well. So now, after we have learnt about the ocean's temperature distribution, the factors controlling the temperature, the next in line is the salinity. Now let's understand about the salinity. What does it basically mean? Salinity of ocean water simply means what? The presence of dissolved salts in the seawater. So how much is the salt content? That is what is the measure of salinity. So salinity is defined as the ratio between the weight of dissolved solid materials and the weight of sample seawater. So in a given sample, how much is the content of salt? That is the basic idea of salinity. So generally salinity is defined as what? As the total amount of solid materials in grams contained in 1 kilogram of seawater. So if we take 1 kilogram of seawater, how much is the content of salt dissolved material in 1 kilogram? Right? So it is expressed as parts per thousand. So remember, many times it is in short written PPT. So it's not PowerPoint presentation, it's PPT, that is parts per thousand, right? So this is the symbol of parts per thousand. An example, 30 parts per thousand means 30 grams of salt in 1000 grams of seawater or 1 kilogram of seawater. So the average salinity that has been calculated of seawater is 3.5%. So in percent, if we say, that is parts per 100. But if we say 35 ppt, it is basically parts per 1000. That is important to remember. So that is about 35 is the standard average value across all the oceans or seawater that we say on the earth. So the value is 35. That is important point to remember. Now let's elaborate furthermore that how do we measure this salinity, what are the methods, in what ways we understand, what are the factors controlling salinity in this session. So first important point, how do we determine the amount of salinity? How do we understand that how much is the salinity? Now before we go ahead into this, let's understand what is a fresh water, what is a brackish water, what is a saline water and what is a briny water. Now remember, just we learnt about the parts per thousand ppt values. So fresh water ppt values is 0 to 0.5 ppt parts per thousand, right? Brackish water 0.5 to 30 ppt and saline water 30 to 50 ppt, and if it is more than 50, then it is called briny water. So remember this classification on the basis of the dissolved salts in parts per thousand, that 0.5, that is the limit for fresh water. So 0 to 0.5 for fresh water, 0.5 to 30 ppt is brackish water, then what we say is saline water between 30 to 50, and above 50 is briny water. So this is the classification. Now the simple way to determine this amount of salinity in seawater is to just do what? To evaporate just 1 kilogram of water and see how much is the residue, because remember, salt and other things that are dissolved are left as residue after evaporation. But there is a problem. What is the problem? This method of derivation is supposed to be overgeneralized and also it lacks accuracy. And why this accuracy is not there? Because we already know that it is just parts per thousand. So it should be accurate. But no, this is not accurate. This is not accurate because there is a variation. It depends on which water you are talking about. Everywhere on the earth, the same amount of salinity does not exist. So if you take 1 kilogram of water in other area of the world, that is suppose in Atlantic, and if you take the same 1 kg of water from the Pacific, it will have different salinity. So this is why it is overgeneralized method if we say that if you want to determine the salinity through this method, right? So because of these spatial and temporal variations, remember the salinity cannot be determined by just evaporation methods. So we need to find out more methods about it. According to this particular principle that we say, constant proportions, we talk about salinity measurement and salinity distribution. So what is this? Let's understand. The chemical analysis and measurement of samples of seawater, remember sampling method and then measuring it, right? So this is called salinometry. Now when the word metry is there, it means we are talking about measurements. So who got this? From Challenger expedition right in 1884, the scientist called William Dittmar. So William Dittmar revealed this fact that composition of ocean water is having something which is called constant proportion. What is this constant proportion? Now let's go into history a little bit. He was the first person who confirmed this principle of constant proportion, which was actually earlier given by Johann Georg Forchhammer regarding this major ions of seawater. So it was confirmed by William Determine after 20 years, right? And that is where this is called Determine's principle or Forchhammer's principle. And this is talking about the composition of ocean water, right? So what is this? The analysis revealed that what happens in the seawater? There is the amount of total dissolved substances in 1 kilogram of sample of seawater, which may change from place to place. Remember, it can be at 25, it can be 30, it can be 35 ppt, parts per thousand. But there is something that remains constant. And what is that? It is the proportion of the elements that is there in this. That remains constant. So this revelation was brought by William Determine in his Challenger expedition, and there he postulated the principle of constant proportion, where he says that the major dissolved constituents, the constituents that are dissolved in the water that comprise the salinity of seawater, occur nearly everywhere in the ocean in the exact same proportion. So basically the proportion is something which is constant, independent of the salinity values. Salinity values will fluctuate, but the amount of minerals or the ions that is there in that particular PPT will be in same proportion. This was proposed in 1884 by William Determine. Now, let's understand furthermore that Determine during his Challenger expedition reported 47 types of salts in seawater. Remember, 47 types, of which sodium chloride, NaCl that we say, remember, NaCl is supposed to be the most common, right? That's why the more of study was done on NaCl or chlorine ion itself. So the principle of constant proportion says that chloride ion is measured to derive chlorinity. Because chlorine is also abundant, that's why chlorinity is measured. And remember, what is chlorinity? It is basically the weight of chloride ion in sample seawater, that is in 1 kilogram of seawater, how much is the chlorine. That is what it was observed. So why this chlorinity? Because it was most dominant constituent of salinity. That is the main reason. And remember how chlorinity is linked with salinity. This we can get through this particular equation. And this equation is given by Thurman Trujillo in 1909. And if you look here, it is what? Salinity is equal to 1.80655 into the chlorinity value. And what is this 1.80655? This is a constant. It is called the chlorinity constant of all oceans. So this is a constant which multiplies to the chlorinity, and then you find out the salinity values. This is a quantitative technique that was devised. So average chlorinity, if you observe, of all ocean is 19.2 ppt. That is parts per thousand, right? So what is the formula? If you put this into this formula of salinity calculation, it is 1.80655 into 19.2, it becomes 34.7. That is what is the rough approximation. Remember, we learnt about the average value of salinity across oceans. It's about 35 ppt. So that is where it is coming from. So chlorinity or salinity are linked together. Salinometer is the instrument which is used to measure the seawater's salinity in an accurate manner. So remember the instrument name, salinometer. Now this is the table. You can pause the video here and look into the table in details. This is having the significant salts in the ocean. Now remember, the most abundant is sodium chloride, NaCl, and percentage, if you observe, it is 77.8% of the total. So this is important to remember. The next number is magnesium chloride, then you have magnesium sulfate, calcium sulfate, potassium sulfate, calcium carbonate, and then magnesium bromide. So remember, these are the 7 out of those 47 salts which was founded by Determine. So these 7 are the most abundant, and apart from these 7 there are 40 more. So remember, what is this diversity of these ions in the ocean water? But maximum abundance is of sodium chloride. That is important to remember. Now let's go to the sources of ocean salinity. Now where does this salinity come into the ocean? Now remember, there are 3 important points in this. Chemical weathering of continental rocks. Remember geomorphology, we have already learnt about the weathering, right? So chemical weathering of continental rocks produce lots of ions, right? And this is transported by the rivers into the ocean. So that is the first source. Then we have next important source coming from within the surface of the earth through volcanic eruption, right? That is through removal of dissolved gases, and this process is called degassing phenomenon, right? So this is important. Then atmosphere and biological interactions also lead to creations of many ions, and that is also dissolved in water. So these are the three major sources that we need to remember, of which the biggest source is this first one, that is river runoff. It is the most significant contributor to the ocean salinity. And chemical weathering, the processes as we remember, carbonation, oxidation, solution, hydration, hydrolysis, chillation, all these are the chemical processes that lead to the ocean salinity that we are discussing. Then factors controlling salinity. These are the 6 factors if you observe here carefully. These are evaporation, precipitation, influx of river water, prevailing winds, ocean currents and sea waves. Then what we have is the melting of ice. So all these factors, basic idea is what? Is water going away from the sea or is it being contributed to the sea? Right? So that is important. So evaporation, water is being taken off. So if water is going out, it means salt concentration is getting more. That is important. If precipitation is there, it means water is being added to the system. It means then salt content will dissolve and it will be diluted. So what happens? Salinity will be lesser. Same happens with influx of river water, that if it is having more salt content which it is contributing, it will increase, right? And if it is having fresh water, then it will not, it will reduce. So that is important. Similarly, prevailing winds, that also we have already learned in the prevailing winds how they are related to the ocean water circulation, right? Through generation of waves and currents, right? Then ocean currents and sea waves. Remember, ocean currents and sea waves have both factors here. Ocean currents and sea waves are of warm and cold nature, right? So that is one factor. If it is more warming happening, it means more evaporation. And apart from this, there is another factor that these waves also hit the surface of the continents and they break particles, and that's where they also lead to the contribution into the salt part, or many materials are contributed due to the waves. So that is also one contributory factor. And apart from that, the polar areas where there is lots of melting of ice, it means lots of fresh water is being poured into the ocean. It means salinity is decreasing. So these are the factors that are controlling the salinity. So if you observe here, this particular diagram, evaporation of seawater, precipitation, river runoff, melting of ice, groundwater flow also to the ocean, and the freezing of seawater. These are the factors that are determining the ocean salinity of particular places. Now, if you want to divide it in terms of spatial distribution, look here, the factors and processes which affect spatial distribution of ocean salinity are grouped. So if you group these factors, how we can group? First are those factors that increase the salinity. So what are the factors? Evaporation, formation of ice. These actually increase the salinity, right? That is important. And there are factors which are decreasing the salinity. It means more fresh water is coming. Precipitation, river runoff, melting of ice. These are bringing water to the ocean. So salinity is reducing. So remember, this is about spatial distribution. But if we go temporal variation on season, remember seawater salinity is also to do with temporal variations. And why? I hope you understand, because of the insolation changes, seasonal fluctuation. So northern hemisphere records maximum and minimum salinity when? During June and December respectively. Because during June the sun is on the Tropic of Cancer and maximum insolation, so more evaporation, so more salinity. So this is a seasonal fluctuation. So that's where temporal variation is also there, apart from the spatial variation, because of these factors controlling salinity. Then looking into the world distribution of salinity, just observe this particular world map as well and this graph as well. Remember, there are 4 distinct zones, that is on the basis of latitudes. So latitudinal distribution of salinity can be done on the basis of these 4 zones. First is called equatorial zone. So this is 10 to 20 degree latitude on north and south of equator. So this is close to equator, this particular zone, right? This particular zone automatically has maximum insolation. But remember what happens here. Because ocean is there, water is there, more cloud formation happens and more water is being poured in terms of rainfall. So what happens? Relatively low salinity is there due to excessive rainfall, although insolation is high. But because of the rainfall factor, precipitation factor, salinity is not the highest. So where is the highest salinity? As we go to this tropical zone towards the Tropic of Cancer and Capricorn, that is where you have maximum salinity, that is about 20 to 30 degree north and south latitudes, due to low rainfall, high evaporation and high atmospheric pressure. Remember, this is a zone of subsidence, high atmospheric pressure, the subtropical high belt, and that is where, remember, maximum salinity is observed. Apart from this, if you go further in the temperate zone, again it is the zone of low salinity, right? That is important to remember. Then subpolar and polar zone is the area of minimum salinity. Remember, this subpolar and polar areas across the world are the minimum salinity areas. Why? Because lots of melting happens and fresh water is being poured in the ocean. So that's where the salinity values go down. And you can also draw this particular graph for your answers when you're writing your answers. This particular graph where you have latitude here. So see the equator zone, it has insolation high, but temperature high is there, but this salinity factor is low because of the rainfall. But if you see in the Cancer and Capricorn, it is peaking up, it is higher, right? So this is important to remember, that salinity is more in tropics than on equator. This is the point to remember. Then going by the regional distribution of surface salinity as well. So remember regional oceanography, Jenkins, he was the scholar, he has divided oceans and seas on the basis of variations in surface salinity. Now we talk about the surface salinity, there are three divisions. So three divisions of the world in terms of the surface salinity was done by Jenkins, and first is the seas having salinity above normal. Above normal salinity is basically what we are looking at. So above basically what? 35, right? So Red Sea, then you have Persian Gulf and Mediterranean Sea, which are higher than normal. Then seas having normal salinity. So Caribbean Sea, Gulf of Mexico, Bass Strait and Gulf of California, these are normal. And seas having below normal, that is lower end. So slightly less is Arctic Ocean, North Australian Sea, Bering Sea, Ostok Sea, then you have Japan Sea, China Sea, Andaman Sea, North Sea, English Channel, Gulf of St. Lawrence, and much below. These are the lowest ones. So you have the Baltic Sea and Hudson Bay in comparison to the normal salinity that we see. So this is whose classification? Regional classification of Jenkins. So you can map these places on the world and see where these places are located, and you can observe a pattern that these sea are located in particular zones where all the factors that are responsible for the salinity are there, right? Then going by the vertical distribution of salinity, again as we talked about the vertical distribution of temperature, and remember temperature is important factor for salinity, accordingly it also changes. So in much of Earth's ocean, what we observe, there is a difference in salinity between surface and the deep zone. So remember, surface zone will have different salinity and deeper zone will have different salinity. So what is this? It is very similar to what we talk about thermocline. Here we don't have thermocline, but we have halocline. Remember, halocline is representing the salt content. So salinity generally increases with depth. That is important point to remember. With depth, remember, salinity increases. But this is a general pattern. There are certain anomalies in the world as well. So there is a distinct layer where salinity increases sharply. Now where is this particular sharp zone? This is the zone. Remember, 300 to 1000 meters. This sharp increase, this is called halocline layer, right? So salinity at a depth is very much fixed. Now remember, in the deeper zone, if you observe, salinity values are almost vertical here. At this point it is fixed, right? Because there is no way that water is lost from this area, right? So not much of water is added, not much water is lost, so salinity remains almost fixed, and that is why we see this vertical point here, right? So as we go deep down, that is where the vertical salinity is fixed almost. And remember, the electrical conductivity of seawater, as salty water is there, so conductivity is measured, and that is where, remember, it is dependent upon salinity factor. So electrical conductivity is being studied, and oceanographers also use this instrument called CTD, which is that conductivity, temperature and depth instrument, to actually understand about this vertical distribution of salinity. Then if you look at certain more examples from the world, the salinity of Great Salt Lake, then Dead Sea, Lake Tuz, all these places are one of the most saltiest places or seas of the world or lakes of the world, right? So you have a list here, if you observe, right? So this is the top 10 list in the world, and you can find more such lists on the web as well. So these are the places where you have maximum salinities. So if you observe the Dead Sea, how much is the salinity value? It is 337. Now remember, 337 is way beyond 35 ppt. Now 337 ppt is excessive ppt, right? Similarly, Lake Tus, it is having 324. So 324 is its ppt. So ppt value is 324 here. Great Salt Lake, if you observe, the value is 317 ppt. So these are one of the most highly saline areas of the world, and that is an important point to remember. Now, apart from whatever we have learned in terms of measurement, the new international program that is associated to this salinity measurement is called ARGO program. So remember this word ARGO, it is associated with the collection of information from oceans using a fleet of robotic instruments. That is the new science and technology based. And where is this name coming from? The name ARGO was chosen because the array of floats work in partnership with the Jason Earth observing satellites, and that is where the name is Jason Earth. And remember Greek mythology, if you know, Jason sailed on his ship the Argo in search of golden fleece, and that is where the name has been kept as ARGO. So remember, ARGO is a program which is linked to the measurements, to the monitoring of this particular international program related to salinity and other features observation through the robotic instruments. That is the new part of the program. Then we have the significance of salinity at last, and why salinity is important. The first point is that freezing and boiling points are greatly affected and controlled by addition of salts. So as we know that pure water, normally the freezing temperature is 0 degree, but if it is saline water, what happens? It is minus 1.91 degrees C. Right? So salinity of seawater is lesser, while the boiling point of the same saline water is higher than fresh water. So this is important to remember. Then salinity and density of seawater are positively correlated. In details, we are going to learn in the sessions to come about density. There will be talking about it also. So the salinity of seawater increases its density, as we know. So more dense, more salt content, right? Evaporation is controlled by salinity of the oceans. So remember, if it is more saline, it will be less evaporatory in nature. It is more concentrated, right? So this is what is important, that if the solutes or salts are there in the water, evaporation rates are lower, right? That is important to remember. And this is the reason why we are talking about ocean salinity in connect to the global climatic regulation. As remember, spatial variation in seawater salinity becomes potential factor for what? For the generation of these ocean currents. Right? So this is important point. And lastly, the ocean salinity affects the marine organisms. Now remember, marine organisms, phytoplanktons, zooplanktons are all dependent upon the salinity of ocean water, and that's why it is one of the most significant aspect, apart from what we know as the global climatic changes that are impacting the oceans. So now, when we have learnt in details the factors related to salinity distribution, in the sessions to come, we'll be talking more on the concept of density distribution. So stay tuned, stay safe, all the best wishes.